Testing 1 2 3. Testing 1 2 3.
Hi. Yeah.
All right. So let's go ahead and start. Today we're going to learn about how to solve equations. So we are learning how to solve linear equations. And this is probably the most fundamental subject in algebra because you'll be using it so much in everything you do. But before we do that, let me ask you, do you know what the difference between this and this is?
Um, the one on the right, 3x plus 9 equals 12, is an equation, and the other one is an expression.
Yeah, good job. So this is an expression, algebraic expression, and this is an equation. Anytime you see this equal sign, you're dealing with an equation. And you remember what these things are called?
Terms.
Terms, yeah, terms. And what are the numbers in front of so what is x? What is that? What is x? Now, I'm not asking you what x exactly is as a value, but what does x mean? What is the
The
name?
variable.
The variable. And what are the numbers in front of the variables? Right next
The
to them.
constant.
They're constants, but there's a specific, so a constant would be
Coefficient.
coefficient, yeah. Anything that's in front of a variable, like 3, so we have 3x, 3a, b, c. The 3's are called variables because they're coefficients, because they're right next to the variables. They're multiplying the variables. Numbers that are by themselves, such as 7 and 12, would be considered constants. Okay, so those are the parts of things you need to know, terms you need to know for algebra. What else did we go over? So let's say we're given something like let's say we're given this expression. Um, how what are the like terms in this expression? Like terms
Uh,
would be, huh?
3x plus 7x, and then, yeah.
Yeah, that's it. So like terms are when you have the same variable and the same exponents for those variables. So we can actually combine like terms. 3x and 7x are like terms, so we can combine them into 10x. So this would simplify, this would be 10x minus 3xyz, and then plus 3x squared. Okay, this would
Yeah.
be the simplified form. If Are these like terms, 3x squared and 5x squared?
Squared. That's
Sorry, 3x squared and then 5x cubed.
no.
Yeah, they're not like terms. They have to have, even though the variables are the same, their exponents must also be the same as well. Okay, so these are not like terms. Okay, so let's get started with solving linear equations. The goal of solving every linear equation is to isolate x. So let's start out with a very simple example. Here we have x plus 3 equals 10. Now, just looking at it, we already know what the answer should be, right? Because we know that 7 plus 3 gives us 10. So that we already know without having to know the algebra what x is. But we need to actually know the technique behind solving it in order to solve much more complicated ones. Okay, this is a very simple equation that anybody in, for example, pre-algebra would know how to solve. So to learn about the techniques of solving equations, you need to understand the goal. The goal is to isolate x. What do I mean by this? I mean at the end of working out through an equation, we want x by itself, where x equals something. Okay, where x equals the answer or the solution. Okay, what we do is we're gonna manipulate the equation using techniques of algebra so that we end up with x equals something. And the technique, okay, the main technique or the method for solving equations is what are called inverse operations. This just means you're going to do the opposite operation on x that's already being done on x. So here we have x plus 3. So what's being done to x? We're adding 3, right?
Yeah.
We're adding 3. So what would be the inverse operation of that? Meaning, what would be the opposite operation of plus 3?
Subtract 3.
Subtract 3, okay? So if I'm adding 3, the inverse operation of that would be minus 3. If I'm subtracting 3, what would be the inverse operation of that?
Adding 3.
Adding 3. And this also works for multiplication and division. Okay, so what would be the opposite of multiplying by 9?
Dividing by 9.
Yeah, dividing by 9. And the opposite of dividing by 9 is
Multiplying by 9.
Multiplying by 9. Good. Okay, so that is the method to isolate x given an equation. It's inverse operations. Now, the other thing you need to know, two things actually, is the addition property of equality and the multiplication property of equality. Now, addition property of equality also applies to subtraction. Okay, that actually occurs a lot in math because subtraction is just adding negative numbers. Okay, so if I have, so here I have 2 plus 2. Okay, that's 4. I can rewrite this as a subtraction problem, or I guess it's the other way. I can rewrite a subtraction problem as an addition problem. So let's say we have 4 minus 2. Well, that can be rewritten as 4 plus a negative 2. Okay, that's why in math, usually they'll call something like this the addition property of equality, and then it'll also apply to subtraction as well. Okay, so this addition property of equality applies to both addition and subtraction, and the same goes for multiplication. A division problem can be rewritten as a multiplication problem. So let's say I have something like 10, and that's being divided by 2. Well, as a multiplication problem, this would be 10 times what? It'd be 10 times 1 half. Because what happens when I multiply 10 and 1 half? It becomes 10 over 2. Okay? It's the exact same thing as a division problem. Okay? That's how division and multiplication are related. So what the addition property of equality means is basically, here we have an equal sign. Whatever you add to the left side, you must also add to the right side to maintain equality. Okay? An equation means we have the same thing on the left side as the same thing on the right side. They must equal each other at all times. So if you do one thing or something to the left side, you must also do it to the right side. Okay? That's what the addition So that's what the addition property of equality means. And the multiplication property of equality means whatever you multiply or divide on the left side, you must also do it to the right side as well. Okay? To maintain equality. Same concept. Okay?
Yeah.
Okay, so knowing about these tools, let's go back to x plus 3 equals 10. And we're ignoring the fact that we already know the answer. Okay? Ignore the fact that you already know, just from looking at it, what the answer is. What we want to do is apply the techniques. Okay? So to isolate x, what I'm going to do is basically I want x on one side. And the convention, or the normal thing that people normally do, is to leave x or to move x to the left side or leave x on the left side and put everything else on the right side. Okay? That's what most people do when they isolate x. Now, it doesn't matter if let's say if you wanted x on the right side. Okay? Here we have x already on the left side, but let's say for whatever reason you wanted it on the right side, that would be fine as well. But it works either way, but it's just people normally want x on the left side. So what we're going to do is we're going to do an inverse operation. So since we're adding 3 to x, the inverse operation of that would be subtracting 3. So we're going to subtract 3. However, since we're doing it to one side, we're going to subtract 3 on the other side as well. Okay?
Yeah.
We're isolating x, and so we're going to subtract 3 on both sides. That's what the addition property of equality tells us. So what happens when we do that? The positive 3 and the negative 3 cancel out, and we're just going to be left with x on the left side. And then on the right side, we have 10 and negative 3. 10 minus 3. What is that?
7.
7. And there you go. Look how we've fully isolated x to one side, and we have a constant on the other side. Everything else got moved to the other side and simplified. So this is going to be our answer. X equals 7. Okay? Very simple. Yeah, very simple problem, but you have to start simple when you're learning new things. So go ahead and try. I want you to try this example by yourself. We have x minus 12 equals 4. And let me know when you're done.
I'm done.
You're done? Okay. Sorry. Okay. So what's being done to x? Well, we're subtracting 12 from x, right? So what we're going to do is we're going to do the inverse operation of that, which is
Addition.
We're going to add 12. But not only are we going to add 12 to the left side, we're going to do it to the right side as well. So plus 12 and plus 12. I'm going to draw a line at the bottom. The negative 12 and the positive 12 cancel out, and we're just going to be left with x on the left side, and on the right side, we have 4 and negative 12, positive 12, which is 16. Is that what you got?
Yeah.
Yeah, good. Let's try another example. Here we have x plus 13 equals negative 18. Try that and let me know when you're done.
I'm done.
Okay. So what would be the inverse operation for this one?
Minus 13.
Yeah. We're adding 13, so we're going to subtract 13 from both sides. 13 to cancel out. We have x equals negative 18, and negative 13 is going to give us what? Negative
31.
31. Good. All right. Let's try an example with multiplication and actually, let's try an example with multiplication and division. So here we see that 9 is multiplying x. So what would be the inverse operation of that?
Divide by 9.
Yeah, divide by 9. But we're also going to divide both sides by 9. So what happens is, 9 divided by 9 cancels out because it's 1. Okay? So we're just left with x on the left side. And on the right side, we have 27 divided by 9, which is
3.
3. Good. All right. Here we have x over 5 equals negative 3. So x is being divided by 5. So another way that you might see this written down is in this manner. Okay, so x over 5, like this, is the same as 1 over 5 times x. Okay, because 1 times x is x, so that's going to be x over 5. So these two are the same thing. Okay?
Yeah.
All right, so x over 5 equals negative 3. X is being divided by 5, so what would be the inverse operation of that?
Multiply by negative 3. 5.
Yeah. And not only are we going to multiply by 5 on the left side, we're gonna do it to both sides. So what I like to do is surround the whole thing by parentheses and multiply by 5. So what's happening here is 5 times x over 5. Or if you want to be more precise, it's 5 over 1 times x over 5. We can cross simplify. So what you end up with is just x. Okay, so whenever you see this, what's happening is the 5s are canceling each other out. So we get x on the left side, and then 5 times negative 3 is what?
Negative 15.
Good. And that's our answer. Okay. Let's try some examples. Go ahead and try this one and let me know when you're done.
I'm done.
Okay. So, like I said, it doesn't matter which side x is on. I normally like it on the left side, but it can be on the right side, and you'll still get the same answer. So 2 is multiplying x. That means all we have to do is divide by 2 on both sides. So on the right, the 2's cancel out, and we're left with x equals negative 20 over 2 is what?
Negative 10.
Good job. So that's the answer, negative 10. Now, I didn't go over something that's very important. What if you wanted to check your answer?
You just plug it in.
Yeah. So you plug it into the original equation. So the original equation was negative 20 equals 2x. So all we would have to do is plug negative 10 into x and work it out. So if we do that, or if we did that, it would be negative 20 equals 2 times negative 10 is negative 20, and negative 20 does equal negative 20. Therefore, your answer is correct. Okay. Anytime you're given an equation and you solve for x, all you have to do is plug your answer back into the equation to see if you did it correctly. Let's try another example. Try that one.
I'm done.
Okay. So, again, same thing. Now, again, you can just this is one of those problems where you can just look at it and know the answer, because the only way you get 0, okay? So right here what's happening is negative 7 is multiplying x. The only way you get 0 as a result is if you're multiplying by 0. So x is going to equal 0 no matter what. Okay? But using the techniques of algebra, we can do the same thing. So we're going to divide by negative 7 because the inverse operation of multiplying by 7 is dividing by 7. And we're going to do it to both sides. So x is going to equal 0 divided by negative 7, which is 0. Okay?
Yeah.
All right. So let's move on to something a little bit more complicated. So those examples were just meant to show you the addition property of equality and the multiplication property of equality. These are going to be slightly more complicated. So okay, so here we have negative 5 times the quantity of 4x minus 4 equals negative x minus 37. Okay, so the idea is the same. The goal is to always isolate x on one side and to move everything else so that at the end of applying all the methods for solving equations, you're left with just x equals something. X equals something.
Yep.
But the first thing you want to do in a lot of situations like this is to actually look to see if you can simplify the expressions. So on the left side, we have negative 5 times the quantity of 4x minus 4. You can simplify by distributing the negative 5. Okay? So let's do that. So negative times 4x is negative 20x. And negative 5 times negative 4 is going to be positive 20. Okay? And then on the right side, we still have negative x and minus negative 37. And at this point, what you want to do is decide, okay, do I want x on the left side or the right side? Well, I want my x on the left side. So how can I do that? I can do that by adding. Notice we have a negative x here. And know that if I add x to that, what do you get? If I have a negative x and positive x, what happens?
They cancel.
They cancel, or in other words, they become 0. And that's what I want. And that's how we can move things left and right. So to move this x to the left side and have it combine with this negative 20x, I can add x to both sides. Okay? So on the right, the x's cancel out. And on the left, we're going to be left with negative 21x, right? Because negative 20 and negative positive 1x is going to give us, negative 20x and positive x is going to be negative 19x.
Yeah.
Okay. And then we have plus 20 equals negative 37. And how can I move this positive 20 to the other side to fully isolate
Subtract
x?
20 on both sides.
Yeah. So I can simply subtract 20 on both sides. And when I do that, the positive 20 and negative 20s cancel. So on the left, we have negative 19x. And on the right, we have negative 57. And how would I isolate x here? So we have negative 19 that's multiplying x. So what would I do
You
to,
divide
yeah,
the negative 19 on both sides.
yep, divide both sides by negative 19. That would allow us to cancel out the negative 19s. So we're left with x equals. Now here we're dividing a negative 57 by a negative 19. What happens if you divide a negative by a negative?
And it's positive.
Yeah, it's positive. So we're going to get a positive 57 over 19. Now, is 57 divisible by 19?
Yeah.
So 9 times 3 is 27. 3 times 1 is 3. Add 2. 57, yeah. So 19 goes into 57 evenly 3 times. So our answer is going to be 3.
Yeah.
Yeah. So let's try another one. And this is going to be your turn. So we have 40 minus 8x equals negative 3 times the quantity of 5x plus 3. Go ahead and try that one. Are you done?
I'm done now.
All right, let's so yeah, so the we can start by simplifying the right side by applying the distributive property. And what happens when we do that? Negative 3 times 5x is
Negative 15x.
negative 15x, and then negative 3 times positive 3 is negative 9. And on the left side, we have 40 minus 8x. And now we can start to isolate x. So how do we do that? Let's say I want x on the left side.
Then you add 15x.
Yep. So add 15x to both sides. And how would I move this 40 to the other side?
You subtract 40 on both sides.
Yep. So we're going to subtract 40. And notice what happens. The 15s cancel out. The 40s cancel out. And sorry, I forgot to put the x there. So negative 8x and positive 15x is going to give us
7.
Good. 7x equals, on the right side, we have negative 9 and negative 40, which is
Negative 49.
To isolate x, we're going to divide both sides by 7. So that allows us to just get x on the left side. And negative 49 divided by 7 is?
Negative 7.
Negative 7. Good. And that is our answer. All right, let's do one final example before finishing this lesson. So it's going to be negative 3 times the quantity of 1 minus x equals 7 times the quantity of x plus 6 minus 1. Go ahead and do that and let me know when you're done.
I'm done now.
Okay. Again, so we can simplify both sides. So let's do that. We're going to distribute the negative 3 across the 1 minus x, and we're going to distribute 7 across x plus 6. Okay. So when we do that, we get negative 3 and positive 3x on the left side equals, on the right side, we get 7x plus 42 minus 1, which is 42 minus 1 is 41. So I'm going to rewrite that as 41 plus 41. Okay. And so let's just rewrite our problem to make it a little bit neater. So we have negative 3 plus 3x equals 7x plus 41. I want my x's on the left side, so I'm going to subtract 7x on both sides. And then I want my negative 3 to go to the other side, so I'm going to add 3 to both sides. And when we do that, the 7s cancel out, the 3s cancel out. On your left, we have positive 3x and negative 7x. That's going to give us negative 4x equals 41 plus 3 is 44. And now to do the inverse operation, we're going to divide both sides by negative 4. That's going to leave us with x equals 40. What's 44 divided by negative 4?
Negative 44. I mean, negative 11.
Yeah, good job. Okay. X equals negative 11. And again, if you wanted to check your answer, just plug in your x value into your original equation. And the homework for tomorrow is, so I'm going to ask you to do right here the addition property of equality, and then the multiplication property of equality, and then solving linear equations in one variable, part 1. Okay, these 3 things. And they're due, what day is today? Sunday?
Yeah.
Yeah. So anytime Monday, tomorrow.
Alright.
Okay, all right. Thank you.